Hello everyone. In this video I'm going to talk a little bit about chemical kinetics. Okay, I'm going to show you how to find the rate law, right, with respect to each reactant with minimal calculation. Okay, so first of all, the rate law of this guy looks like R is equal to K, which is the rate constant, right, times the concentration of A to some power times concentration of B to some other power y. Okay, and our goal is to find x, y, k, and r based off of this table, based off of these experimental values. Okay, so let's just focus on finding x and y in this video. Okay, because finding r and k is a relatively plug and chug part. Okay, so let's focus on finding x and y. In order to find x and y, we first pick two trials from the table, right? We first pick two trials in which all the reactants are held constant except for one. Okay, so pay attention to trial 1 and trial 2 here. In these two trials, A is held constant at 0.1 concentration, whereas B is changing from 1 to 4. Now, going from 1 to 4, what type of change is it? B is pretty much quadrupling, right? B is going from 1 to 4, so B is quadrupling. Now, what effect does that have on the rate? When B is quadrupling, rate is going from 0.035 to 0.07, right? In this case, it's pretty obvious that it is doubling, right? But in some cases, if it isn't, then all you do is you take the second number, right? You take 0.07 and divide that by the first number, which is 0.035. You just do that calculation, and you end up getting 2 for this particular trials. Okay, so this 2 tells you that the rate has doubled when B has quadrupled. So then how do we find y for B here? Okay, now all you do is just you take this number 2 and then divide that by the amount that that B has changed by. Okay, so 1 to 4, that's quadrupling. That means it has changed 4 times, right? So you do 2 divided by 4 and you get half. This half is your y. So that means in your rate law, when you write your rate law after finding everything, you do b to the power of half. Okay, that's how you find y. Now let's try to find x again. In x again, we're trying to find the concentration with respect to A, right? The order with respect to A, and then so we have to pick trials in which B is held constant, right? Now if you look at the table, we see trial 1 and trial 3. In these two trials, B is held constant at the concentration of 1. Whereas A is changing from 0.1 to 0.2, which is pretty obvious that it is doubling, right? So what effect does doubling of A have on the rate? Well, it is going from 0.035 to 0.14. Again, if it isn't obvious how much this has changed, do this trick. 0.14 divided by 0.035. And when you do this, you get 4. Again, take this 4 and divide by the amount that A has changed by. Okay, it has gone from 0.1 to 0.2, which is double, right? So that means it's a 2. So do 4 divided by 2, and you end up getting 2. And this 2 is your x. So eventually, when you write your rate law, right, you get R is equal to K times A to the power of 2 times B to the power of half. So that means the rate with respect to A is the second order with respect to A, and it's half order with respect to B. And the overall order of this reaction is going to be 2.5. Just add these two guys together.